2025 didn't go as planned.
535 marks. बस थोड़े से मार्क्स से रह गई. बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया. इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P2CB, जिससे फिजिक्स पे होगा डबल फोकस.
Don't just make it your last try, make it your best one yet. Join Infinity Learn today.
Hello, good noon my dear students. Welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry. How are you all doing? Please confirm, can you all able to hear me? Yes, that's good. Today we are going to discuss about thermodynamics part 2, where we are going to see various calculation part of the thermochemistry as well as thermodynamics. So, hi Nitesh Kumar, hi. Yes, that's good. Good afternoon everybody. So, here I just want to say thermodynamics is the grade 11 topic. In this grade 11 topic, it is most important part of the chemistry, where you are going to expect one question directly or two questions indirectly from the thermodynamics. It is connected to physical chemistry, organic chemistry as well as inorganic chemistry. So, it is going to be such an awesome topic where we are going to discuss about the feasibility of a chemical reaction. In the part 1 of the thermodynamics, we discussed about just thermodynamic parameters, and we seen the basic terminologies and the work and heat and other terminologies. And today we are going into the join in the deeper version of the thermodynamics. And this particular session is useful for the students who are preparing for NEET examination, dropper as well as a 12th grade, and if you are 11th standard student, it is going to be very important. And let us see some more details about this. So, before going for the thermodynamics, a little promotion, and please like this session, share with your friends and subscribe to Infinity Lane NEET YouTube channel. Bacho, and I want to introduce you, if a student is preparing for NEET examination for dropping, we want to provide you Sri Chaitanya Academy by Infinity Learn. We are introducing Atreya. So, what is this Atreya program? If you are doing good, well, and we want to change the status from the dropper status, like from I didn't do to I will do it. Hai na? Zoom. Hi. So, please like the session everybody. I want to see those students who are online, please like the session. And you see, crack your NEET examination, introducing Atreya program by Sri Chaitanya Academy by Infinity Lane. They are India's most powerful NEET preparation program. It is for the repeaters especially, and it is P2CB physics daily, twice a day, and along with your physics and chemistry and biology. You can see here this Atreya, it is double focus on physics along with biology and chemistry. You can see the course structure. The course is started May 23rd. You don't worry, if you enroll, you are going to be every week a new batch is going to be introduced. So, you will be joining in this session. So, a new batch. So, days of the week with the classes Monday to Saturday. संडे का छुट्टी है, ये छुट्टी में आप असेसमेंट भी कर सकता हूँ, थोड़ा सा टेस्ट भी लेना चाहता हूँ. Should I purchase it? You please click the link that is available and provide your details, and you are going to see everything about that. Okay, and you can see here duration of the each class is going to be 90 minutes. Okay, and it is 1 hour 30 minutes, and you will be having 3 classes per day. The program is designed in such a way that you won't be having pressure, and this is scientifically designed. You see 3 classes per day. उसमें 2 concept class होगा, 1 practice session होगा. Okay, Ravi, and you just click it and you will get the details, right? And the classes per day and classes per week, there are 18 classes per week. In that you will be having a double practice class for physics. You know, in the NEET examination, whenever a student from the biology background, NEET examination, physics is going to be a nightmare. So that is only not only the problem you face it, it is the total students, 23 lakh students have the same problem. But we want to take it on us and we will make you, physics is no more difficult to you and physics is going to be a super awesome subject for you. Ravi, you can see here there are 465 classes and 240 DPPs and dedicated practice session 120. You see 465 classes ke liye 120 practice sessions. So concept delivery as well as the doubt resolution and the quality questions at the level of, at the depth of NEET examinations will be discussed here. And after class, you need not have to worry to prepare a notes. Notes will be given in the PDF format at the end of the session. And this is a very important. When you join in any online education system, the practice sessions are going to be, you will be joining in the session in hundreds of students. But here, a separate batch will be given to you at 20 to 25 students. So in that small batch, an expert faculty is making you to practice the questions so that you will be having a chance to discuss directly with the faculty and you can have a customized doubt resolution and you see how impact it can give you. Definitely nobody is on the online platform, this facility is given, batch size does matter. So you can feel as if you are in a small tuition point. And also the coverage of total 11th and 12th up to the NEET examination will be given. Okay, zum, nice. Price details में दिया जाएगा, एक बार देखो. Just watch it and click the link everybody. Wonderful. Now my dear students, yeah. So please like this session and we are talking about thermodynamics here and this is the link for those completed NEET examination. You want to see the rank and college predictor and you can enter your details and you will find the way forward for your, what college you are going to expect it. And what you learn in thermodynamics. And I just want to give the list of the thermodynamics topics here. First law of thermodynamics and entropy, and today most concepts are going to be discussed, entropy, and you're going to be second law of thermodynamics and Gibbs free energy change and spontaneity and thermochemical equations and Hess law of constant heat of summation. Among these thermochemical calculations, we completed thermochemical equations in the previous class, Hess law as well as thermochemical calculations as well. 3 are completed. I just want to take this session into 3 to 4 sessions and this is the third session. First session we completed thermodynamics. Now I want to focus more on the entropy in today's class and second law of thermodynamics and Gibbs free energy change and the spontaneity. So actually what we are saying is thermodynamics is an important aspect in the physical chemistry. It allows whether the reaction takes place or not. So the concept of spontaneity, it does matter. So get ready to discuss about all these things and please like this session, share with your friends and subscribe to Infinity Land YouTube channel. Those who are online, please like the button, press the like button so that the like buttons also visualize it to me so that session ka josh badh jata. Okay. So we discussed about the first law of thermodynamics. We will see the more details about this now. Right? Any doubts regarding the previous session or you want me to just go through it quickly? Okay. Now let us see a system and surrounding and a universe. You see, a system is a part of universe and which is under thermodynamic study. And except system, the entire part of the universe is called surroundings. Entire part of the universe is called, this is surroundings, and the system and surroundings are separated by a real or imaginary interface that is called as a boundary. And the boundary can be diathermic or adiabatic. Diathermic means it can exchange the heat and adiabatic means it cannot exchange the heat. Are you getting or not? And here types of systems you see: open system, closed system, and isolated system. Open system is a system which can exchange both mass, matter, and energy. And a closed system is a system which can exchange only energy but not mass. Whereas an isolated system which can exchange both mass, which cannot exchange both mass as well as energy. It is isolated. It is an isolated. Okay, it happens in the thermos flask kind of things. You understand, dear children? Right. Now let us talk about the thermodynamic functions, state functions and path functions. So take a pen and paper and write the noteworthy points, which is very important, my dear children. Here I want to say one thing here. You want to have this kind of a session from an expert faculty, you need to join in a coaching center and have to pay huge amount of money and travel for a long way. But on the YouTube channel, we are providing all these valuable lectures by the expert faculty for free of cost. So make use of this, take a pen and paper and write the noteworthy points. Hi, Nitesh Kumar, hello, Zimzam, and please use the chat box generously, can have an academic discussion. Okay, so any doubt, if you ask in the chat box, I am going to respond it. So this is a so valuable session. Please like it and support us. एंड हम बच्चों के लिए कुछ भला करने का कोशिश कर रहा हूँ, आपका तरफ से भी थोड़ा सा भला करने का कोशिश करो बेटा. लाइक द सेशन, कैसा भला कर सकते हैं? लाइक द सेशन, शेयर विथ योर फ्रेंड्स एंड सब्सक्राइब टू इन्फिनिटी लर्न नीट यूट्यूब चैनल एंड प्रेस द बेल बटन सो दैट आगे कौन सा क्लास आने वाला है. सो एवरी सेशन अपडेट विल बी गिवन टू यू सो दैट यू विल राइज. एंड आई एम गोइंग टू टेल यू माय डियर स्टूडेंट्स हियर, यू मे थिंक दैट आर सिर्फ यूट्यूब क्लास अटेंड करने तो आपको नीट एग्जामिनेशन निकाल सकता है. येस, ऑफ कोर्स यू कैन अटेंड एंड यू कैन क्लियर नीट एग्जामिनेशन. एंड नॉट ओनली यू कैन क्लियर नीट एग्जामिनेशन, यू कैन बी ए टॉपर आज ऑल्सो. यस, आप सही सुना, नीट एग्जामिनेशन में टॉपर में निकाल सकते हैं. येस इट इज, एंड इट ऑल डिटरमाइन योर विल पावर and how you follow our lectures and how you follow our suggestions and our guidelines. The entire NEET YouTube channel is working on result oriented sessions has to be delivered. So this is not a color showing YouTube session. We are the content creators and we want to deliver a very good lecture, and you will not be deceived and you will be getting a very good support from our side. You please follow our channel and you will get the best of the content from the NEET channel. Okay, thank you very much, my dear students. Here thermodynamic properties are two types. One is a state function and another one is a path function. I want to say one thing here. Let us have a discussion. H2O, what is the state of H2O? It could be a liquid state, it could be a solid state, it could be a gaseous state. है ना? अरे H2O is a molecule. It is generally it is available in liquid state. So temperature is the parameter. It can tell you at 25 degrees centigrade it is a liquid, right? And if it is minus 10 degrees centigrade it is a solid. And if it is 100 degrees centigrade it is a vapor. Okay, make it 0, not a problem. So temperature is the parameter used in thermodynamics which can define what state it is. Are you getting or not? Yes, that is clear. So state function is a property which defines the thermodynamic state of a matter, and it is given with a capital letter P, pressure, V, volume, T, temperature, and these are all the state functions. And depends, this state function depend on initial state and final state of a thermodynamic process. And it doesn't bother about in what path it is used to convert from one state to another state. Are you getting or not? While the other case, the path function is heat and work. And path function depends on the initial state and final state, and also how this state is changed, the direction and the path of the process, that is called as the path function. Heat and work are the path functions. Here heat, so that is given as a Q, and work is given as a W. You know, state functions are indicated by capital letters while the path function is indicated by small letters, right? So you should have a clarity before you jump into the details of the subject, right? Clear? And Ravi and all students, please ask any doubt if it is, and use the chart box for that. Okay, you have extensive properties and intensive properties. What are extensive properties? So, intensive properties. Let us talk about the intensive properties of the physical properties that do not depend on how much matter is there. I want to take a water, pure water. In a glass, what is the density? It is 1 gram per milliliter. You take a tumbler of water, again the density is 1 gram per milliliter. You take a tank of water and you measure, the density is 1 gram per milliliter. So, density of the water is going to be an intensive property. Are you getting or not clear? Are you getting or not clear? That's good. And also, extensive properties of the physical properties that depend on the amount, depends and do not depend. That is the difference, bacho. And it is clearly mentioned. That's the reason why you just take a pen and paper. Take a pen and paper and you can use it. And you take the mass, you take the volume, you take the number of moles, everything is extensive property. Okay, you take a density, refractive index, okay, molarity, it is all intensive property. Some examples here, melting point, boiling point and density. Here some examples, mass, energy and everything comes in here. I just want to take here on extensive properties, these are the least, and intensive properties, these are the least. Sir, do we have to memorize this? You just feel it, you will understand. Take the parameter, you understand what is the meaning of that parameter. It depends or do not depend. And imagine some example. And you know one thing, energy, entropy is extensive property. While intensive property, if you take an extensive property in mole per liter, per mole, per gram, it is going to be intensive property. I want to say entropy. This is entropy. It is an extensive property. While molar entropy, it is going to be intensive property. This is a simple trick, I can say. Very important, if you take anything per mole, it is said to be intensive property, right? And you just see here, intensive property is density, okay. Now you can see the intensive property is density, here it is given density. If you take density is equal to weight by volume. What is the density? It is an intensive property. You can see it is an intensive property, and weight is an extensive property, and volume is an extensive property. So the ratio of extensive property 1 and extensive property 2 is going to be intensive property. So NEET एग्जामिनेशन में क्रैकी क्वेश्चंस करने को ये लॉजिक इस्तेमाल करो बच्चों. होप यू अंडरस्टैंड क्लियर. And let us see here, homogeneous system, heterogeneous system. In a thermodynamic system, it contains more than one substances, components. If all components are in the same physical state or a phase, is called as a homogeneous system. If different phases, it is said to be heterogeneous system. Okay, and this homogeneous system, heterogeneous system, we extensively use in the equilibrium chapter, right? And talking about, so any change in the parameter, what is a thermodynamic operation? You take a cube of ice in a bowl and keep it on the top of the table. So what will happen? Ice melt, so that water is formed. So आपको क्या चल रहा है? H2O solid state से H2O gaseous state तक बदल रहा है. So there is a change in the state. So during this process, heat is absorbed, and this is what is called as a thermodynamic operation. In thermodynamics, we are going to discuss about how much heat is absorbed or released during this operation. If a system changes from one state to another state, this operation is called as a thermodynamic process or thermodynamic operation. Okay, change in parameters, state parameters of a system is called a thermodynamic process. You have various types of thermodynamic process. Okay, so zim-zam. Okay, so let's say adiabatic process. What is the adiabatic process? The process that takes place without absorbing heat or without releasing heat from the system. So heat quantity of the system kept quiet. So that is what is called as adiabatic system. That is what you say, dq is equal to 0. Q stands for heat. And you see, isochoric process. The isochoric process is the process which takes place at constant volume. So ये process में volume हमेशा constant होगा. So that is called as a dV is equal to 0. ठीक है? Any doubt? That's good. And isobaric process, the process which takes place at constant pressure, so that is called as dP is equal to 0. You can see, my dear children, how to acquire this isobaric process. So you can take a gas in the cylinder by movable piston, isobaric process, and a closed residue container, isochoric process, volume constant है ना. And if you take that system in a thermo flask, you can say it is the adiabatic process. Learning thermodynamics is very simple, and you can say isothermal process. So dt is equal to 0. What I want to say, what makes the difference between the adiabatic process and isothermal process? I want to hear from you, my dear students, please. I want to hear from you. Anything? You just tell me. So Zimzam, Ravi, what's the difference between isothermal process and adiabatic process? So isothermal process, system is not thermally isolated. It can exchange the heat from system to surrounding. So during a process, if work is done, so it has to be absorbing or releasing the energy. So it can, isothermal process में temperature can go in or come out of the system. That is called isothermal process. ताकि इसका temperature हमेशा constant ही होगा process का हिसाब से. ठीक है बेटा? Thermodynamics gives a lot of support. So actually what happens? Those preparing for NEET examination, so more inclined to study biology, and of course some time in chemistry. You people just get rid of the physics, and you people get rid of the physical chemistry while you are getting the numericals. So when you see the numbers, when you see the numericals, when you are solving something calculation, automatically you are going to be morally distressed. So no worries, I am going to give you the scratch level discussion, so that I am going to solve the questions along with you, and you follow the methods that I follow, and you can use that, and you can do better and the best for your next upcoming examinations, and I can guarantee you that. Yes? Any doubt? Jim Zam, any doubt? And take a snapshot, everybody. Yes, and also you see thermodynamic processes. You see thermodynamic process, isothermal process, isobaric process, isochoric process, and adiabatic process. You see in the isothermal process temperature is constant, so dT is equal to 0. Isobaric process dP is equal to 0, and isochoric process volume constant dV is equal to 0, and you can say adiabatic process dQ is equal to 0, right? And the process in which the system returns to its original state after a series of successful journey. So A converted into B is converted into C is converted into D is converted into A. So this is what is called a cyclic process. In this cyclic process, internal energy change is going to be 0, but work done will not be 0. And you can see the other thing, reversible process and irreversible process. The process which takes place in a single step is called as an irreversible process. And this irreversible process is going to experience the equilibrium only at initial state and final state. Whereas a reversible process, a process which takes place in several infinitesimal small steps, that is called as a reversible process. So each and every step you are going to get the equilibrium phenomena, and it is practically impossible to achieve it and hard to achieve it for the reversible process. And maximum work done can be extracted from the reversible process. Okay, so the process in which the system and its surrounding cannot be simultaneously returned to their initial state after the process has been completed is called irreversible process. But any time it can be reversed, it can be a reversible process. And you can see here the main process in the chemical thermodynamics, you have very important thing, isobaric and isothermal process where PT are constant. Generally in experience, I want to say these are the processes that are taking place. And isochoric process and isothermal process. So two couple of things can be together. So the most experienced numericals you are going to get it from here, my dear children. And a chemical reactions takes place under these conditions, beta. So it has to be mentioned in the question where it has to be PT constant or VT constant. Generally T constant वाले देखने हैं रोहन, रौनक, hi, like button मारो जल्दी. So next process derivatives of quantities. So we have thermodynamic functions. One is a state function we discussed, another one is a path function, रौनक. And also we see PV work done. Yeah, 12th का आपका late है section online. Mushtaq, what you want to say? आप कुछ बोलना चाहता हो, जल्दी बोलो. 12th का topic पढ़ाना. You want me to teach 12th topic? So if you want, next week I am going to schedule some solutions for electrochemistry, doesn't matter, or organic chemistry भी. आपको जो चाहिए आप सजेशन में डालो, कमेंट बॉक्स में डालो और चार्ट बॉक्स में डालो. Definitely I am going to use that. Ronak? Yeah. So let's say PV work. When a gas is taken in a cylinder and it is having a movable piston and it is thermally not isolated, so that heat can go in and heat can come out, right? And initially it is going to be V1 volume and it is going to be V2 volume. When the pressure of the gas, and this is the external pressure, जब pressure gas का greater than external pressure होना तो क्या होगा, piston upward direction में move करना चाहता हूँ. Yes. आप 12th को डेट हो, आप ऑनलाइन क्लासेस है. Okay, because I take online classes for the 11th and 12th also, on the B2C sessions and the B2B sessions. Okay, anyways, this is a YouTube channel, and this YouTube channel, if you have any topic of interest to discuss, and I am going to schedule a session according to your request. ठीक है रौनक? So for 12th standard जो syllabus है ना, it will start from the next week. After completion of this Nirman live sessions on the content based, we will be starting a new series of practice sessions and most expected questions and key concepts from key points, and we will be having a mock examinations, and we will be having a mock discussions in the YouTube live itself. Okay, so don't worry, let us follow here. So what happened when this happens, no? So how much work is done? Yeah, that work can be done simply by taking work done. I don't want to derive it. So work done is equal to minus P external and delta V. Delta V क्या बोलना चाहता हूँ आपको? Delta V is equal to V2 minus V1. V2 minus V1. This is V1 and this is V2, and this is going to be delta V, right? And during this process, work is done in this way, so that heat is going in this way. Okay, this is the work. And it is a cascade system. That is the reason why it is called gas expansion. If you go into the more details about this, and unnecessarily you are going to get confused. Ronak, please like the button. Okay. So I don't want to say sign conversion is very important, beta. Why this minus is given? Work is done by the system. If the work is done by the system, W is going to be negative. Work is done on the system, W is going to be positive according to the chemistry IUPAC conventions. And if heat is absorbed to the system, Q is going to be positive. Heat is released out of the system, Q is going to be negative. That's what I want to say. So find the work done on each case. Two cases are given. Let us do some concept and follow the questions. Concept is followed by the question. Okay, here you just see when 1 mole of gas expands from 1 liter to 5 liter against atmospheric pressure, okay, allowed to enter into the vacuum. So in the vacuum, what happens now? External pressure is going to be 0. When this external pressure is 0, work done will be 0. And if it is done from, yes, it is work done is going to be 0, right? And if it is from 1 liter to 5 liter, so delta V is going to be V2 minus V1. This is called V1, and this is V2, and delta V is going to be 4, and it is going to be P delta V. P is external pressure 180 में दिया, and it is going to be 5 minus 1 is going to be minus 4 liter atmosphere. When you solve the question now, you won't get the answer, you won't see this answer in the multiple choice, rather it will be given in the joules. I'll tell you 1 liter atmosphere is equal to 101.3 joules. This is a super important conversion. Are you getting or not? Clear? Any doubt? And we'll see more details about this. We'll see more details about this. Yes, Ronak, here heat is defined as the amount. What is the heat here? Heat is defined as the amount of energy which flows between the system and surroundings when a thermodynamic operation is done. And the heat always flow from hotter body to colder body, high temperature to low temperature. What makes the heat and what makes the temperature? Heat is a kind of energy. So when we say energy in the thermodynamics, we can say heat in the thermodynamics, whatever. Heat is of various types, that's a different matter. And the temperature, what is the temperature? Temperature is a scale which measures the heat, right? You can have a Fahrenheit and centigrade, Kelvin, whatever it may be. So don't confuse heat and the temperature. Heat is a quantity, temperature is a scale. Got it? Got it? Yes, wonderful. Now we can see when the heat is going into the system, that is called a positive. When the heat is coming out of the system, Q value is going to be negative, system to surrounding. When work is done by the system, you can say done by the system, it is going to be negative. And if somebody is doing work on the system, that is going to be positive. It is very important, right? And let us directly go into the difference between heat and work that I already mentioned here, right? So Mushtaq and Ravi, Zim, please follow this, and you can see internal energy in the first law of thermodynamics. Internal energy, the sum of all kinds of energy in the body, in the system, is called as internal energy. So let us follow here. If this is a system, okay, this is a system. I just want to take you to the next class. So if this is a system, first law of thermodynamics says energy neither be created nor destroyed, but it can be transformed from one state to another state. And also, if some quantity of some energy is disappeared, equal quantity of the another form of energy should be appeared. And also, if some quantity of a type of energy is disappeared, equal quantity of work should be done. So energy conversions and work energy conversion is given by the first law of thermodynamics. So in general, we can say energy neither be created nor be destroyed, but it can be transformed from one state to another state. Understand? Clear? Any doubt? Okay, let us go into the details of the first law of thermodynamics. Here we can see here, this is a system. ये सिस्टम इनिशियली इसका इंटरनल एनर्जी U1 था, ओके. नाउ इसको थोड़ा सा एनर्जी देना चाहता हूँ Q, एंड साइमल्टेनियसली वी डू सम वर्क ऑन इट, ताकि इसका इंटरनल एनर्जी थोड़ा, I have taken some water and I have given some heat to this. Energy of the water is increasing, na? So energy means internal energy is changing, na? So that what happened, its internal energy changed to U2. So internal energy U2 is equal to कितना होगा बेटा? U2 is equal to U1 plus, and it is Q plus W. ये भी दे रहा हूँ, ये भी कर रहा हूँ. So that U2 minus U1 is equal to Q plus W. I want to say U2 minus delta U is equal to U2 minus U1. So delta U is equal to Q plus W. You understand? Clear? Got it? So this is the mathematical version of the first law of thermodynamics. That same thing is explained here. समझ में आ रहा है क्या? Mushtaq, Zim, Ravi, those who are on online, please let me know your doubts. Okay, let us go into the details of this. Application of the first law of thermodynamics on various processes. Application of first law of thermodynamics, various processes. Take a pen and paper, everybody write down here. So an isothermal process, the process which takes place at constant temperature is called isothermal process. So as we know, for delta U is equal to 0 for isothermal process, mind it. And also for first law, so we know that delta U is equal to Q plus W. So ये वाला 0 होगा तो Q is equal to W, है ना? And it all depends on the exothermic or endothermic, and work is done on the system, work is done by the system. Are you getting or not? So this is what is called isothermal process. अगर कुछ doubt है ना तो जल्दी पूछना, जल्दी. So everybody who are online, please click like button and please like this session and share with your friends and subscribe to Infinity and NEET YouTube channel. Okay, so let us talk about isothermal expansion. When the piston, this is a cylinder, and if you heat is given, the piston is going to rise. So when you talk about the P versus V, so PV is going to give you a curve like this, and the work done is going to be area of shaded part. So as you know, P is inversely proportional to V as long as the temperature is constant. So isothermal dt is equal to 0. So that is called isotherm, right? And here I just want to say the process takes place slowly as the pressure in this piston is reduced. The gas tries to expand because you are heating here, right? And also the expansion tend to cool down, but the heat reservoir gives heat into the temperature, heat into the system, so that the system temperature has to be maintained constant. Understand? Clear? Moving ahead, dear children, another one is the isothermal compression. ये expansion का है and it is talking about compression का है. When compression takes place now, heat is given out. Always mind it here, the heat flow and the work flow. It is a cascade process in the isothermal process. And here you can see heat flow and the work flow. It is a cascade process, isothermal process. When you see it is a compression, volume is decreased, the direction of the graph is going to be in this way, and you can see the direction of the graph is going to be in this way. Understand? Clear? Now, so here it is given the same way on the other side. Okay? Now moving ahead, the microscopic nature of the first law of thermodynamics. I am discussing everything. Dear children, it is going to be a super awesome session. The internal energy of a gas is confined in a container is defined as relative to the coordinate system fixed container. And viewed at the microscopic level, the internal energy can be taken in a number of forms, such as like microscopic forms like kinetic energy of the molecules, the potential energy of the constituent molecules in the system, and also you can take internal energy stored in the form of chemical bonds and released through the chemical reaction. When the bond is formed, energy is released. When the bond is broken, energy is incorporated. Class 10 here, Krishna, it is a class 11 and a class 12 levels. Okay. Now you can see the total of all kinds of energy inside the system is called as the internal energy. Hence the total internal energy, you can see the internal energy is sum of translational energy, rotational energy, vibrational energy, intermolecular force, electronic and relative, all kinds of energies are there, right? And you see here the enthalpy. Now I just want to talk about what is enthalpy. Internal energy is the sum of all kinds of energy of a system at constant volume. But when it comes to the natural processes, all natural processes that are taking place are against to the atmospheric pressure, the pressure is constant. So you want to study the natural process, it is required to understand another thermodynamic state function is called as enthalpy. Enthalpy is nothing but heat at constant pressure. Internal energy is heat at a constant volume. Mind it, these are the major technical difference between the internal energy and enthalpy. That is given as enthalpy is nothing but internal energy, but is something extra. What is that? Some work done. So enthalpy is equal to internal energy plus work done. So work done is of majorly whatever the work done we convert into PV work done. PV is equal to nRT. That is the reason why enthalpy is equal to internal energy plus P delta V. V is the volume variable, and here it is PV is equal to nRT, so that during a process number of moles of gaseous system can be changed. So that you can say P delta V is equal to delta nRT. So delta H is equal to delta U plus delta nRT, that is a very important. So you can say at constant pressure, combining the first law, equation 1 becomes like this: delta UH is equal to U plus PV by definition. What is enthalpy? If somebody asks you, by definition it is true. Hi Krishna. Okay, Mushtaq, you please, everybody please stay tuned and discuss the things here. I just want to say, what is delta N? Heat exchange at constant volume is said to be internal energy, that is delta U is indicated in chemistry. In some books it is given as a delta E as well. If some actually the books are copied from one to another, delta U, okay, delta U or delta E both are used interexchange, है ना बेटा? And this result is valid for all substance on isochoric conditions, क्योंकि volume constant रहना पड़ता. Okay beta, and this result is valid for all the substances involving an isobaric process, volume is constant. ठीक है? And definite quantities also. Talking about the heat capacity, that is very important. We are getting into the more into the physical aspect here. So from now onwards, for the next 10 minutes is going to be physics. What is the meaning of heat capacity? Let us say this is a piece of wood, and just heat it in the flame for 2 minutes and you can touch it. Assume this is not catching fire, okay? And a stainless steel rod, you just keep in a couple of minutes in the fire and you touch it. You feel it so hot, है ना? Or otherwise, I just want to say, you take water and same quantity of oil and you heat it. You heat it. So what happens? It is going to absorb heat. It is going to absorb heat. Just take 2 minutes, okay? If you just put your finger inside it, you feel it is hot, but no injuries happens. If you put your finger inside it, you are feeling it is injured. So why so? Oil has a capacity to absorb more heat in it, so that if you put finger, you will get injured. है ना? Boils will come. Are you getting or not? This is the way you need to understand thermodynamics. So the heat capacity of a system is the amount of heat required to raise the temperature by 1 degree. 1 degree. So these heat capacities are two variants: specific heat capacity and molar heat capacity. So specific heat capacity is the heat required to raise the temperature of 1 gram of substance. So if that is given as C is equal to dq by dt, the heat required to raise 1 gram of substance by 1 degree is called a specific heat capacity. If it is for 1 mole, it is called molar heat capacity. The difference between the specific heat capacity and the molar heat capacity is also very important here. And in the case of gases, we have two types of capacities. In the case of gases, okay, heat capacity at constant volume, heat capacity at constant pressure. If it is for 1 gram, that is called specific heat capacity. If it is for 1 mole, that is called molar heat capacity. You understand? Now you can say, so heat capacity at constant pressure, that is called CV, and this is CV is equal to dqv by dt, you know? And the first law of thermodynamics you can apply: du is equal to dq minus dw, and dw is equal to p dv, because du is 0 for isothermal process, and at constant volume it is written as du is equal to dv, and it is given as the heat capacity at constant volume is given by CV is equal to du by dt at constant volume, and change in the temperature and the change in the internal energy, okay. And if it is at constant pressure, it comes to be Cp, And let us talk about the Cp. So, this heat capacity at constant volume is defined as the rate of change in internal energy with temperature at constant volume, right, or specific heat capacity at constant volume. Are you getting or not, dear children? Fine. So, the other terminology, heat capacity at constant pressure. So, that is given as at constant pressure it is nothing but enthalpy change. So, that I want to say Cp is equal to dH by dt at constant pressure. In that case, you can see it is defined as the change in enthalpy with temperature at constant pressure. Hi Krishna, Mushtaq, Ravi are noting down the things. And also, for 1 mole of gas, heat capacity at constant pressure, that is Cp, is always greater than heat capacity at constant volume. When you are solving some questions, by looking at this, comparing at this Cp and Cv value, and you can assess whether it is going correct or not correct, right? That is very important, always mind it, Cp is always greater than Cv. And how they are mathematically related. These are called molar heat capacities. C is equal to du by dTV, and for ideal gas, since U and internal energy and enthalpy are only function of temperature, hence the subscript P and V and Cp and Cv equation can be dropped, which means you can simply write, so Cp is equal to internal energy by change in temperature, and Cp is going to be enthalpy by change in temperature, and it you can write this as like this as well. So, you can drop it P, only 2 parameters, right, and you can write this delta H is equal to Cp dt, and you can calculate the numericals based on this formula. Okay. And I am giving you the series of formulas where you can expect a question, my dear children. Those who are online, please ask any doubt if you have. And talking about the relation between dH Cp dt is valid any substance other than ideal gas at an isochoric process. Validity is also important. The relation du Cv dt is valid any substance other than ideal gas at isochoric process. What are the formulas that are there? You just to take the validation about this, and you can do it. And some formula is coming into the mind directly, blindly, don't take this, so that you are going to trapped. NEET examination is all about accuracy and precision and the speed. So, speed later we can learn, and accuracy, precision is important. I am giving you the formulas and the validations. It is valid for isochoric process, it is valid for only in isobaric process. Okay. Now, the relation between and Cp and Cv. You have the Cp minus Cv is equal to R, and my Cp Cv ratio is equal to gamma, right, and this is called Poisson's ratio. So, for monoatomic, the degree of freedom, let it be, that comes on the physics, and Cp value and Cp value, and it is going to be monoatomic gamma is equal to 1.67. For diatomic, gamma is equal to 1.4, and for tri or a polyatomic it is going to be 1.28, and you have to memorize these values. And it is there again, this particular table, it is going to be double benefit for you, okay. And also you can see some more details, Now entropy, what is entropy? Krishna, Ravi, who are there online? It is degree of freedom. You can see this is completely packed, all the atoms of the molecules. You can see the molecules are little relaxed, more relaxed, some more relaxed. So here it is a random, high randomness. So here it is low randomness, organized, and here it is a disorganized. So there should be a thermodynamic property which measures the degree of freedom or degree of randomness or degree of disorderedness. That is what is called as entropy. So let's see the difference between the entropy and enthalpy. You are going to see enthalpy is defined as H refers to the measurement of total heat content in a thermodynamic system under constant pressure, while entropy is denoted by S, and it measures the level of disorderedness of a system. Yeah, let's go into the details about the entropy here, comparison of entropy and enthalpy. So for whenever you want to do best, you need to have a clarity of what you are handling it. So granular level I am explaining you, my dear children. Look at here, entropy is the measure of randomness and enthalpy is the measure of heat at constant volume. Joule Kelvin inverse, Joule mole inverse, these are the units. And requirements, no limits, entropy का limit नहीं है, but enthalpy at constant pressure at temperature are the limits. Okay, बच्चों who are online, please like the button, requesting you to like the button. And entropy is measured as Q by T, and enthalpy is measured as internal energy plus work done, PV work done, and it is a property, it's a kind of energy. Okay, it's a thermodynamic state function, and system always try to have the minimum entropy and maximum enthalpy. So maximum entropy and minimum enthalpy change. Okay, anyways, let us talk about the second law of thermodynamics. Second law of thermodynamics. I just want to give you a last twisty question. So this law of the statement, thermodynamic predicts direction of the nature of the change. First of all, it do so with the help of the state function S called entropy of system. And you want to say during an irreversible process, entropy of the universe always increases. I mean to the sum of internal and sum of the, so you want to say entropy of the universe is equal to entropy of the system plus entropy of the surroundings. And this entropy, total entropy for irreversible process is going to be greater than 0. So I want to say a process that takes place spontaneously to increase in its entropy. And this is what is called as the entropy formula, and it is Ts is equal to dq reversible by T, and d surroundings is equal to minus dq reversible by T. It is a minus. Okay, so entropy, so dq by T, and this is the second law, mathematical formula of the thermodynamic second law, right? Dear children, let us go into this. So second law of thermodynamics is proceeding to the spontaneous. What is the meaning of a spontaneous process? The process that takes place by itself, may be by proper initiation, may not be by proper initiation. Rolling a stone down the hill is a spontaneous direction, is downhill proceeds unaided. So nobody has to do work during this process, it will do by itself, right? Hi, Mana and Rana, hi. Are ek bar like button dabao. Right. So a process which may takes place by itself after a proper initiation is called as a spontaneous process. Right? A spontaneous process may take place instantaneously or very slow. That depends on the kinetics of the process. So what is the meaning of a non-spontaneous process? So the process which cannot take place on its own, and a process never feasible unless you do work done on it. and flow of water uphill, flow of heat from the colder body to hotter body. These are all non-spontaneous process. ठीक है बेटा? Hi, Manan. And you see, rolling down a stone down the hill is a spontaneous process. You want to reverse it? The rolling of a rock uphill is a non-spontaneous process. Right? Clear? And why this is spontaneous, why this is not spontaneous? Non-spontaneous process. Okay? And we'll see when the gas is enclosed here and evacuated a bulb, and you just open it, all the gaseous molecule diffuses and moving here and there, and the diffusion is a spontaneous process. And you want to take all the gas molecules from one side to another, and you want to convert like this, it is a non-spontaneous process. You understand the details. And here want to say a system, and here I want to say system and surrounding, it is actual by T and moving ahead. The prediction of spontaneity of the process, that is important. Prediction of the spontaneity of the process, everybody. So, if the total entropy change in the process is positive, then the process can be spontaneous. You can't say it must be spontaneous, it can be spontaneous. Mustaq, Krishna and Manan Rana. And you can see the system and the surrounding should be greater than 0 for a spontaneous change. And if the second law of thermodynamics is developed during the course of development of cyclic engines, second law was discovered while studying the efficiency of the steam engine. Carnot cycle isme nikalna hai. And we don't study Carnot cycle in chemistry. And you see, so Soddy-Carnot pointed out for the cyclic heat engine to produce continuous mechanical work, it must exchange heat with the two bodies at different temperatures without cold body to discard heat. So, engine cannot function continuously. So, it is useful for the development of the most efficient engines. As far as the chemistry part is concerned, we have to stop somewhere and we go into the more second law of thermodynamics statement, why it is said that. And it is impossible for a system to undergo cyclic process whose sole efforts are the flow of heat from a heat reservoir and the performance of equivalent amount. Don't worry, technical definition दे रहा हूँ मैं, बाद में इसका आसानी भाषा में आपको पता चलेगा. And performance of an equivalent amount of work by the system on surroundings. The key term is above statement is cyclic engine. And if the first part of its the operation when the engine do work, heat is absorbed and expansion on takes place. Second part, it must return to original state and its contrast, and it must lose heat. I want to say a system cannot perform its work without compensation. That is what is called as the second law of thermodynamics. What is the compensation? The compensation in the form of increase in the entropy, and that is given. So, entropy change in isolated system, these are the various mathematical formulas that can be definitely helpful to you. dq upon T from a process A to B is going to be d system from the A to B. And also Krishna Manan, you can say system minus dq by T from A to B is supposed to be greater. I want to say entropy of the system plus entropy of the surroundings is greater than 0. He wanted to say this. Are you getting or not clear? Fine. Fantastic. Now we can say entropy calculation process involved in ideal gases. These formulas are very important. So, this is going to be delta S is equal to NCV ln T2 upon T1 N or ln V2 upon V1. This is one formula. And also for an isothermal process, T is constant. So, ln T2 upon T1 is cancelled. So, delta S is going to be n r ln V2 upon V1. Okay, and talking about an isochoric process, it is going to be volume remains constant, this is lost, so that delta S is equal to NCV ln T2 upon T1. Yes, Manan. And when to use this formula, depends upon the process you take into the action. Understand? Clear? Any doubt? Bacho? And this is about the entropy. And one more session I just want to schedule to talk about Gibbs free energy change, and we will conduct a special session for MCQs on thermodynamics. Get ready, and hope you enjoyed today's class. Those who are online, please, once you just press the like button, and we are done from today for today, and we'll meet with more stuff in the next class. So when is our next class, आपको कैसा पता चलेगा? Please subscribe to Infinity Land NEET YouTube channel. Okay, everybody who are online, please like and please subscribe to NEET Infinity Land YouTube channel. Thank you. Signing off, Suresh, Faculty of Chemistry from Infinity Land. Thank you. Bye bye.